Good morning. Today will be in English. Generally is in Polish, all this presentation, but today, because the problem concerns many scientists from various countries working in Egypt, especially in Nile Valley. So this lecture will concern clays and silts of Nile Valley, starting from Idfu up to Delta. During more than 30 years of work in Egypt, I collected some samples from many places. I did examination, mineralogical, of these sedimentary rocks as well as of pottery from many sites. And this knowledge I like to present you, maybe will be helpful for some for some scientific activities. So were collected samples. We will start from Idfu, later Herakonpolis, next Armand, region of Deir el-Bahari, region of Nagada, next Abydos, Asyut, region of Castel Saga, this means Fayum Oasis, and next will be Helwan, and Benha. Next will be Tel El Daba, investigated by Professor Bitak, and site Tel El Farka, investigated by Professor Czałowicz and Dr. Marek Chłodnicki. So let's start from Idfu. This will be slightly long, but a presentation, but there is a lot of details important for scientists working in pottery, in Egyptian pottery of various periods. So it's not easy to present these old things in very short time. So the samples for investigation from area of Idfu were collected below the bridge present in Idfu, in the slopes of the banks of Nile. This is a photograph done below this bridge, let's say between Idfu and Herakonpolis. As you see, the river is great, big, and weather is not typical for Egypt. It's foggy and windy, and in the banks of Nile appear various kinds of silts. Of course, there are old sediments, because now it's not, the position is not very strong, rather is erosion. As you see, the banks are slightly eroded, and the datation of the silts is impossible. So we may say that there are old sediments at secondary position. Probably in part there are Sahaba silts, in part other silts, and because we are on the left bank, the Nile is going to the north, to this direction. It's necessary to say that along all river, all Nile, left bank sediments are different, are other than of other compositions than right bank sediments, because there is the position of material from west desert, and there are mostly limestones and gravels, sands, limestones, and on the right side we have the same rocks at some places. This means limestones, gravels, and pediments of various types, sands and so, but we have material transported to the Nile by rivers, not now of course, but earlier, but rivers from East Desert. There are granitic rocks, there are diabases and various metamorphic rocks and veins of quartz and many various rocks. So generally sediments of left bank, near left bank or building left bank of the Nile are other than sediments building right east bank of the Nile. Of course, additional material is transported from the south, and there we have material from Sudan, not too much, but material from area of Aswan. So admixture of various components of granitic rocks, typical this Aswan granitic Carboniferous age. And when we look under the microscope to the sediments from region of Edfu, we have plenty of dark spots, yellow flakes of muscovite, fragments of metamorphic rocks from eastern desert. There is meta mudstone or meta silt, let's say, and other minerals typical for rocks, sedimentary rocks of West Desert. So fragments of limestone and others. And there is mineral composition, example of mineral composition of rocks from Edfu, this sedimentary, let's say, silts. Main components, there are clay minerals, represented mostly by kaolinite, because material is redeposited from the rocks covering Theban limestones. The Theban limestones long time were covered with red soils, so-called terra rossa, and because of weathering, because of various phenomenon, these clays covering Theban limestones will wash out from the hills and deposited in the banks of valley of Nile Valley. So the main component of clays at this area is clay minerals. The main component is kaolinite. There are various types of kaolinite, but I will not go to details. Generally kaolinite and small admixture of illite. When we come to delta, in delta, main mineral, clay mineral is montmorillonite, smectite, other type discussion from where it was redeposited at other, but we will talk not about genesis too much, we will talk about composition. Next is quartz. As you see, feldspars, potassium and plagioclases, there are minerals originating from Aswan granitic rocks. Fragments of sedimentary rocks that are mostly limestone and small pieces of cherts and flints, and rare magmatic and metamorphic rocks from East Desert. There is muscovite, biotite, sorry for mistake there, and heavy minerals, various, because at the left side there are mostly sulfides. At sediments of left bank of Nile, at this area there are mostly sulfides, and admixture of zirconium, garnet, and minerals typical for granitic. It's admixture of granitic rocks, and is admixture of organic compounds, organic matter, not identified, difficult for identification, and there is diagram showing what is where in the amount and so. Of course, this is general knowledge about clays from region of Edfu because there are diversified. There are various sediments, but this is most representative, and this material is good for preparation, of course, of pottery, because of presence of kaolinite, and material examined by me from archaeological sites documents confirm that to this primary sediment were added crushed material. This clay was so fed for the production of pottery. Even in Nagadian, Nagada 2, Nagada 3 cultures, there is pottery containing admixture of crushed, very fine fragments of flints and fragments of limestones. And Heracompolis is located, not maybe good map. There is Edfu, there is Armand, somewhere there under the rainbow. And there is photo from investigation from archaeological excavation conducted by scientists from Penn State University, and there's a lot of various kinds of pieces of pottery, and generally this site is localized on Sahaba sediments, Sahaba silts, reworked by peoples, damaged. We did a lot of boreholes and various examinations. So, coming to the details, there is example of Sahaba silt from region of Heracompolis. Quartz, not well rounded. What is interesting that this material not typical for aeolian transport. Clay minerals are disseminated, very small flakes, difficult for determination using microscopy methods. Small flakes of muscovite, small admixture of small grains of limestones, and general look like this. Mineral composition is present there. Clay minerals very near identical like in Edfu, slightly higher amount of quartz, and feldspars and plagioclases from granitic, Aswan granitic rocks, sedimental rocks, mostly pieces of limestones and small fragments of cherts. There are rare magmatic rocks, probably fragments of rocks redeposited transported from East Desert. So there are some metamorphic rocks like sandstones, mudstones, difficult for identification, and serpentinites. There are some kinds of gneisses. There is a big variation of various kinds of rocks, of magmatic rocks, no metamorphic rocks, and there are other minerals. And in Sahaba silts from Heracompolis, we have heavy minerals, mostly sulfides from Theban limestones and Cretaceous sandstones from West Desert, from Sahara, transported by river from West Desert, and small amount of heavy minerals typical for rocks present in East Desert. Some grains of apatite, some grains of garnets, not not how to say, not not good for identification, not helpful in identification of source of material. And organic matter at this area of Heracompolis there is 2.3. There is diagram showing how it looks like. Region of Armand. Region of Armand was examined by a Polish-German mission in 80s of 20th century. We did survey along the left bank of the Nile, and we discovered a lot of archaeological prehistoric sites of various age, starting from Paleolithic to early dynastic. And we did examination more or less at this area during a few seasons. We did boreholes at so. And for this area, typical are sediments like this. This is Sahaba from this area, Sahaba formation. As you see, there is silt at this part, and upper there are gravels mixed with the stones of originating from the Jebel, Theban limestones. And this is sedimentation of Nile, delicate sedimentation, and this is sedimentation of materials conducted, transported by streams coming from the Jebel into the Nile Valley. As you see, all this material is reddish because of admixture of clays constituting earlier red soil, so-called terra rossa. And at some parts, sediments of the same age are various in color, because if material was transported from East Desert, the Sahaba formation is gray, sometimes slightly greenish, and if it's transported from the Jebel of Theban limestones, built of Theban limestones, there are clay minerals, mostly kaolinite, red, pink, and so. So the color is not indicative for determination of stratigraphy, because the same layers of the same age are very differentiated. And under the microscope, sediments from this area look like this. We have admixture of quartz transported from the desert, probably by wind. In part, its roundness is various, some heavy minerals and structures parallel, typical for sedimentary rocks. Mineralogical analysis show that clay minerals are the most important component, 50%, and quartz, various, aeolian and redeposited from Cretaceous sandstones from West Desert, and potassium feldspar. Part, of course, is from Aswan, but part, of course, is from East Desert, from granitic rocks present in East Desert. Plagioclase is not too much. Sedimentary rocks, admixture of small fragments of sedimentary rocks. There are mostly fragments of Theban limestones, flints, sometimes not too much Esna shells. As you know, in profiles below Theban limestones we have sequence of sediments, so-called Esna shells. There are shells composed of kaolinite and illite intercalated with layers of limestone, slightly dolomitic. Not traces of magmatic rocks, fragments, and metamorphic rocks. Practically there are no biotite, only muscovite. Heavy minerals, rare and not indicative. Organic compounds, not too much. It's example of one sediment from area of Armand near our site, excavated in 80s by Polish-German mission. Deir el-Bahari. So it's practically not, there are not samples from Deir el-Bahari because it's too high in morphology for presence of Nile sediments. Maybe there are at some places preserved, but we didn't find this. And additionally, all material is reworked by people's digging tombs and make buildings, building temple of Deir Hatshepsut in Deir el-Bahari, etc. But we collected samples at the place where was outflow of the stream of valley of Wadi, where on the contact between valley of Deir el-Bahari and Nile Valley. There are some small fragments preserved of Sahaba Formation. At this place, Sahaba Formation, there is photo on the bank of the river. At this place, near to the bank of river, the sediments of Sahaba are damaged, weathered, mixed with sediments of Nile, etc. So to collect good samples representative for Sahaba formation is not easy, but we collected some, and under microscope they look like this. It's a lot of organic matter because of this sample is dark, and small fragments of various organisms, so-called grass and various some admixture of burnt organic material, so-called charcoal, and quartz. Of course, under all this admixture, there is present clay minerals. There are present clay minerals represented mostly by kaolinite too, with admixture of illite. And if we look to the detailed analysis, microscopic analysis, we have 50 more or less 50 to 50 minerals, clay minerals and quartz, and feldspars, not too much, traces absent. Fragments of rocks, mostly fragments of Theban limestones and Esna shells. Sometimes small fragments of flints from Theban limestones. Magmatic 0.2, etc. Minerals, heavy minerals are not indicative. Various. There are some pyroxenes, there are amphiboles, there is apatite, there is zircon, not indicative. Heavy minerals from Aswan, from East Desert, and from local Esna shells. It's complete mixture, not indicative. And organic 3.3, but at many places much more. Generally, independently of the proportion between clay minerals and quartz, this material is good for preparation of pottery. We did examination using this material. we fired this material, and we obtained, let's say, laboratory pottery of quite good quality. Nagada. We visited Nagada during our excavation in Armand. At this time in Nagada worked Professor Barocas from Italy. He did examination in Nagada. He showed us many interesting features and houses of Nagada culture, of course a lot of pottery, architectonical structures, and many interesting details. And I took sample from his trench, where under Nagadian, let's say, constructions, under this were present Sahaba silt, this one. And under the microscopy, it looked like this. As you see, slightly other picture than in earlier outcrops, in earlier sites. There is mostly organic matter, clays, and quartz. The Nagada site is localized at special place near of the bank of the Nile, but material sediments, local sediments, contain mostly clay transported by Nile and quartz redeposited by wind from surrounding area. Because from Nagada to Jebel is quite long distance, and river were not enough strong to transport fragments of limestones probably. And this material, these quartz light grains, were transported most probably by wind. The size of these grains is up to 0.1 millimeter, not big. And Nagada, this material is perfect for preparation of pottery. And mineral composition look like this: clay minerals, mostly kaolinite, quartz, fragments of rocks. At some places there are small fragments of limestones, sometimes flints, metamorphic rocks, 0.2, very rare, traces of muscovite, traces of heavy minerals, and organic matter. And of course there are variation of silts of Nile in Nagada, various materials, but this I think is most representative, typical for Nagada, because we did some examinations of small fragments of pottery, and in pottery from Nagada this composition more or less is repeated. So during Nagada culture they used probably natural silts. They didn't mix with crushed material. It was material, original material was perfect for production of the pottery. Abydos. Samples from Abydos were collected near of temple in a small trench. We collected this material during our excursion to Abydos, where we visited German mission working in temple and surrounding area. And in one of trenches we collect samples of unknown age, and this material under microscopy look like this. It contains a lot of quartz, and what is interesting, quartz grains are mostly sharp, there are not too much grains perfectly rounded. So material is probably originating from Cretaceous limestones from West Desert of Sahara. How it happened that it's collected there and deposited there is difficult to explain. These sediments from this trench near a temple in Abydos is maybe not typical for this area, sediments from this area, and is not very good for production of the pottery. When we look for mineral composition, the situation look like this, and as you see, clay minerals not too much, 47%, quartz 41%, and traces of feldspars and plagioclasts. Probably they are originating from East Desert, because to Aswan is so far. And sedimentary rocks, let's say, going from Kenya to the north, on the right bank of Nile, we have identical sediments like on the left bank. Up to Kenya, starting from Itfu to Kenya, on the left bank we have mostly sedimentary rocks. On the right bank we have sedimentary rocks and magmatic and metamorphic rocks. Starting from Kenya to the north, situation changed because on the both banks we have limestones, Theban limestones, and behind, on the right bank, behind hills, behind Jebel, we have East Desert, and transportation of material from East Desert to the Nile is reduced at starting from Kenya to the north. So we have mostly local materials. This means redeposited terra rossa to the Nile, and admixture of limestone, Esna shells, and of course others, but not too much, small quantity. Asyut. Sample from Asyut we collected near of the bank of the river on the left bank, near the road. It was a small hole, let's say, filled up with the material removed probably from the Nile at secondary position. So material is not representative for all local silts, but it was only one chance to collect samples and make investigation. Material is of course local, but what is the stratigraphy, at which place it is present, how it's old, this sediment is difficult to say, but it contains a lot of not clay material, so silts, admixture of quartz, admixture of limestones, etc., etc. This material is not perfect for the preparation of pottery, but was interesting to see what it is. And under microscopy it looked like this. It's plenty of quartz, as you see, these light grains, and organic matter, probably transported by Nile, fragments of flora, tissue, grass. We don't know what is this, difficult for identification. There are admixture of flakes of muscovite and small fragments of limestones. This, for example, it's not on the photo too much. There is limestones, Theban limestones, and analysis show, microscopic analysis show that clay minerals are there is not too much clay minerals, mostly quartz. Fragments of sedimentary rocks, Theban limestones, fragments of flints mostly, magmatic rocks, 2%. It's probably material from Kena, Wadi Kena, transported to the Nile. Metamorphic rocks, the same, admixtures of material from East Desert, muscovite biotite is absent, and organic compounds. Castasaga, there is this blue, this is a fragment of Fayum Lake, and localization of Castasaga, where we spent a few seasons digging Fayumian A and Fayumian B sites and proto-dynastic and Middle Kingdom sites investigated by Professor Joachim Schliwa. And this area, of course, is completely other sedimentation than in Nile Valley, because at time of sedimentation of Sahaba formation in Fayum, so-called Paleomoeris at this time, about 10 up to 12,000 years ago, were deposited lake marls and diatoms. So completely other sediments. As you see, it's interesting for observation. Contact of two type of sediments. These are laying near flat, and it documents that the bank was relatively far from this place to this direction, and these sediments were deposited at time where the lake was smaller, and the bank edge of the lake was near. So this is document for oscillation of the level depending of the oscillation of level of the lake depending of rains, because this lake does not contain outflow. So it's in the past lake react on the rains, changing the volume. Where was rain, the lake was enlarged. When it was dry, lake was reduced, and peoples at this time, of course, migrated along to the oscillation of the bank of the lake. If lake was big, people sit relatively far from the center of the lake. If there was no rains and lake was smaller, they came to the center of the lake, near to the center of the lake, according to the migration of the bank of the lake. So at this moment, lake of sedimentation of this layer, lake was big, and people sit there, and at this time, lake was smaller, was no rains, and people sit somewhere there on the land, because people like to sit near of the water, because they fish, they need water for drinking water, and so. Under the microscopy, sediments of age similar to age of Sahaba formation look like this. There are organic compounds, traces of diatoms, and traces of skeletons of mollusca, small grains of quartz, and mostly calcite. Of course, this material was not useful for preparation of pottery, but in tertiary hills surrounding lake near of the Castasaga, we have clay stones, relatively hard with admixture of calcite, but after grinding and mixing it with water, it was possible to obtain material useful for preparation of the pottery. And we did examination of Fayumian A and Fayumian B pottery, and it's seen that some vessels were produced of local tertiary mudstones. They crushed, they mixed with water, and next they tried they produced vessels, various. And mineral composition of sediments of age similar to Saba Formation at the region of Castle Saga look like this. There are mostly fragments of sedimentary rocks. This means mostly limestones and organic fragments of skeletons of organisms. Hell1. In Hell1 we examine right bank of the Nile near Japanese gardens, Hell1 University. More or less at this place there are outcrops of sandstones and mudstones, and there are natural outcrops, and this material was redeposited at Hell1 to the Nile. So at the region of Hell1, at this place I showed before, look please, on this bank, practically there are no chance for material useful for production of the pottery. There are in the river and in the land on banks there are mostly silts built of quartz, redeposited sands, and so. Under microscopy this material look like this. Not too much clay minerals, fragments of these sandstones cemented with iron, minerals, black, and not too much clays. And when we did examination under the microscopy, clays are 12%. This means nothing for preparation of pottery. And there is the collection of various components. And we have fragments of magmatic and metamorphic rocks, very rare, of course at second position. This is diagram. Benha Tela Trip. This Tela Trip Atribis were conducted excavation by Professor Karol Myśliwiec, and during time of excavation I visited the site, and were collected samples. Benha, this area were great excavation, and we together with Professor Anna Szymańska, we did examination of terracottas, small figurines made of clay, very beautiful, of local clay, and during this time I was chance to collect primary material for examination, local silts, and we did examination of small fragments of terracottas. This is area of Benha, and this is silt from Benha. As you see, it's very delicate, very small grains, a lot of clay material, and we have there as kaolinite as well as montmorillonite between clay minerals. This clay material, this silt, was specially prepared for production of terracottas because terracottas were produced in special forms. After, let's say, clarification of the silt and the removing of small grains of quartz and other grains, clay mineral was prepared in form of, let's say, plastic mass, which was introduced to the forms, and these figurines were obtained from forms. Later, after drying, forms were opened and figurines were dried and later fired in fire and produced, painted, and so. Very beautiful things. Very small publication about it. And mineralogically, in Tel Aviv, local silt is mostly built of clay minerals. As I said, smectite and kaolinite. This is important because in Nile Valley, going to the south, to the upper Egypt, we have mostly kaolinite, and going to the delta, we have more and more smectite. There is one idea I tell you later because of what it is, but at the end of story. As you see, no feldspars, very rare small fragments of sedimentary rocks, small flakes of muscovite and organic compound, perfect material for production of pottery. Tel El Daba. In Tel El Daba, I visited Tel El Daba and I did examination of pottery from Tel El Daba for two Austrian scientists, and I did a lot of analysis. By the way, I collected samples for mineralogical samples of silts, for local silts, for examination, and its area picture is not good, but it was done many years ago on Orvo film, so is as is. And silts from Tel El Daba are of very good quality for production of pottery. They are composed mostly of clay minerals, mostly of smectite, with small admixture of illite, and as you see, mass is homogeneous. Practically without special preparation, it's useful for production of the pottery. Mineralogically, clay minerals 83, quartz near 15, and practically nothing more. Very rare other admixture, and not indicative. And organic compounds are repeated in all silts of Nile. Everywhere is organic compounds, various amount, but there is. And Tel El Farha, our site, investigated by direction of Professor Chałowicz and Marek Ładnicki. There is plenty of clays. This is the site, so-called Eastern Comb, Central Comb, and Western Comb. Oh, sorry. We did a lot of boreholes on the area of excavation and on the area in front of water canal. There is the water canal. Now it's water canal, and before it was branch of Nile. And we examine clays because was of course local production of pottery, and we examine clays silts of Nile obtained from boreholes. There is Ali making boreholes and Dr. Wasilewski collecting samples, and deeper under the sands of Gezira there are present silts. We examine these silts, and what we know, the silts are very fine material, let's say slightly too fat for production of pottery, so to the preparation of pottery were added quartz, mostly sand built of quartz. And interesting is that in material from boreholes we obtain cores for mineralogical analysis, and under the microscopy we observe small grains of not only quartz and flakes of muscovite, but we observe plagioclases, sharp grains plagioclases, and potassium feldspars. Probably it's material, aeolian material of volcanic origin. Of course, reworked, weathered, and so on, but this maybe is in part explanation of the presence of smectite in Nile silts, not kaolinite like in Upper Egypt. There is present smectite, mostly smectite, and probably part of this smectite is secondary after volcanic glass, because in Tel El Daba, Professor Bitak discovered under the big blocks of architectonical structures, he discovered small fragment of volcanic glass, and were done examination of this volcanic glass, and it was confirmed that this volcanic glass type of pumice, this type of pumice was of identical composition like pumice of Santorini. So probably part of sediments in delta is not, there are not sediments deposited by Nile water, but sediments of aeolian origin connected with magmatic centers, with volcanic centers in Mediterranean area. And this is important because, of course, other products we obtain if we burn clays composed of kaolinite, and other pottery we obtain if we burn, if we produce pottery using material containing montmorillonite, smectite, because during firing of kaolinite is changed to the mullite, synthetic hard material typical for porcelain. Natomiast, but if we produce pottery using clay containing smectite, if we overheat this material during firing at temperature 800-850 centigrades, it start to be porous. So overheating of pottery produced using smectite clay leads to the destruction of vessels. But if we produce pottery using kaolinite, it's impossible overheat, because even if we overheat, this pottery will be of good quality. And in Farha, we had some small fragments of overheated pottery similar to the slag, porous, overheated. The temperature was more than 800 degrees. And there is mineral composition of clay from Tel El Farha. Dominating clay minerals, mostly smectite, and we have small amount of feldspars and plagioclases, sharp grains of Aeolian origin, some muscovites. So this is example, of course, because about silts from each of presented places we may talk long time, but for general knowledge, I think for people's working in pottery in Egypt, this data maybe will be helpful. Of course, science will go forward, and we will have more and more new data, more precisely done examinations and so. But at the moment, at the start, this collected knowledge concerning mineral composition, sedimentation, technological parameters, I hope will be useful for my friends working in Egypt. So thank you very much.